Hello students, it's Mr. Wilsey, and in this video we're going to be looking at the Algebra 1 objective on systems of inequalities. Now, let's look at the first problem here. Graph the linear inequalities on the grids below. Use a straight edge. You may shade lightly with your pencil or shade with a colored pencil. Now, in order to watch this video, I want you to do these problems with me, except you're going to create your own grid and your own axes on graph paper. So let's start with problem A. So we have an inequality. Y is less than or equal to 2. And we want to graph that. Now, I hope that you recognize that this y equals 2, let's put that in a thought bubble, y equals 2 is the equation of a line, and it's the equation of a horizontal line, and it would look like this. Okay, so y equals 2 is that line right there, because along this line, all of the points have a y value of 2. Okay, but we are graphing an inequality in this case. So what we want to graph is a whole region that has y values less than or equal to 2. Now, in order to indicate that, we either have to graph above this line or below this line. Well, the y values less than 2 are down here, so we're going to shade below the line. Now, I kind of did that quickly, but this line should be a solid line, just the way I drew it. The way I know it's a solid line is because there is a line here. It's less than or equal to. Okay? So this means that it has a solid line. A solid boundary line is what we call it. This is the boundary line. Okay? So we can draw the boundary line and we can pick which direction we're going to shade, and that's all there is to it in graphing linear inequalities. So let's try the next one. Y is greater than negative 2 over 3 times x plus 3. Now, you should be able to easily graph the equation y equals negative 2 over 3x plus 3. So let's quickly graph the equation. Let's see. Y-intercept is 3. The slope is negative 2 over 3, so rise is negative 2, run is positive 3, and so on. Okay, so the graph of the line would fall along these points here. Now, do we make it a solid line or a dashed line? Well, here there is no bar beneath the inequality sign. That means that we make a dashed line, a dashed boundary line. Keep forgetting the boundary. Okay? So, the boundary line is going to be dashed. Now, the reason that we draw it dashed is because points on that line are actually not a solution to that inequality. However, all the points, let's see, above or below? Above. All of the points above that dashed line are solutions to that inequality. Notice that I shaded above the line because y is greater than that line. Okay? That right there represents the line, and we're looking for y values that are greater than the line. So y values that are greater are above here. Okay, now let's take a look at the next two problems. This is going to be slightly different because now we have a system of linear inequalities. That means we have two inequalities. And we're going to graph them separately in the same way that we did up here, but then we also have to shade in darkly the overlap region. So watch how we're going to do that. Let's graph the first inequality in purple. Let's say that it was an equation, y equals x minus 1. I would graph, let's see, y-intercept is -1, slope is 1 over 1, so rise 1, run 1, and so on. Okay, so the first boundary line is going to fall along that line, and it's going to be dashed. Okay, dashed. Use a straight edge. Perfect. Now, let's look at the second line. Let's graph it in red. Sorry, the second inequality. It's going to be solid because there's a bar beneath the inequality sign. Now, y is less than or equal to 2x plus 1. Let's see. We're going to go up 1. And then rise over run is rise 2, run 1. Okay, that's the slope. Rise 2, run 1. Okay, and then I'm going to draw a solid line. Okay, now I forgot about this, but we need to also shade. Okay, now let's look back at the purple. Y is greater than x minus 1. That means we're going to shade above the purple line. Shade above the purple line. And if you want, we can, well, let's not do that, but we can shade above the purple line, just like we did over here. Shade it above the line. Now we're going to shade below the red line. Y is less than or equal to 2x plus 1. So we're shading above the purple and below the red. Now that means that the overlap of those two regions is going to be right here. Do you see why? We have 4 possible regions to choose from. Either up here, down here, over here, or in this region where we ended up shading. This region right here is the only possibility out of these 4 that are above the purple line and below the red line. Okay? So this is just the cleanest way to graph a system of inequalities. Excuse me. Now let's look at the next question here. We are asked, is -2, -3 a solution to the system? Well, -2, -3 is right here. Is that a solution to the system? Now this could get kind of confusing because you should know that a solution to a system of equations is the intersection point of the two lines. But in this case we have a system of inequalities. We're not too terribly concerned about the intersection point of the boundary lines. We are concerned about the overlap region. Now that point is not in the overlap region, but the intersection point still would be a solution to the system of inequalities if both boundary lines were solid. Okay? So for example, if we had a solid line and we shaded over here and we asked, is the intersection point of this system of inequalities a solution to the system? In this case it would be yes, because both boundary lines are solid. But if either one of the boundary lines is dashed, that means that the intersection point is not a solution. Okay? And that's the case that we have here. The purple line is dashed. So the intersection point is a solution of the red line, but not of the purple. So it cannot be a solution to the system of inequalities. So I'm going to write down purple line is dashed. Okay? Now let's look at the next system of inequalities. Y is greater than or equal to -5x plus 1. That's the first one. I'm graphing in purple, and it is going to be solid because I have the bar beneath the inequality. So let's graph this real quick. Y-intercept is +4. Slope is -5 over 1. Okay, so let's graph that with a solid line. And then the second inequality, y is less than or equal to 1 over 3 times x plus 1. Y-intercept is positive 1. Slope is rise 1, run 3. I'm going to go backwards. Again, this is going to be a solid line. I'm sick today. Okay, let's figure out if we're going to shade over here, up here, over here, or down here. Which area are we going to shade? Let's see. Let's look at the purple line. We know that we want to shade above the purple line, because y is greater than or equal to that. So we're going to shade above the purple line, which means we're either going to shade over here or over here. And then we want to shade below the red line. If we're shading below the red line, then the only possibility is right here. Okay? This is where we're going to shade. So, there's our shading. Now, finally, is 4, 2 a solution to the system of inequalities? Let's see, 4, 2 is 1, 2, 3, 4, up 2, right about here. Okay? Now, it is just barely inside the shaded area. It's not quite on the red line, and even if it was on the red line, that would be okay, because it still would be a solution to the system. But it's inside the shaded area, so yes, it is a solution, because it's inside the shaded area. And that is it for this objective on systems of linear inequalities. I hope this video helped to clarify things for you.